So now in this video we're going to look at another example of series resistance. It's related to voltage dividers, but in any case, when it comes to series resistors, when you put them in series, their resistances simply add up. So if you put a 1000 ohm resistor and a 100 ohm resistor in series, you end up with an equivalent of 1100 ohms of resistance. And so with 11 volts, 1100 ohms of resistance, you're going to have 10 milliamps, 0.01 amps of current flowing through here. So the power supply has to provide 10 milliamps, and 10 milliamps goes through each resistor here while they're in series. That's the basic property of series components. They have the same amount of current going through them. Now, to do so, they have to divide up the voltage. And so that's what we see here. So this is one reason why you might see a low value resistor with a higher voltage supply, is that something else is limiting the current to a safe amount, which means a low voltage will build across it. So we can easily put 1 volt across 100 ohms and be completely safe. So that'd be 0.01 amps times 1 volt would be 0.01 watts, which is really low for a quarter watt resistor. So in any case, that's what we have going through here, and we can also do the calculation. So we know it is 10 milliamps, so that means it's 10 volts divided by 1000 ohms for the 1000 ohm resistor, and 100 ohms has 1 volt across it. So now we come to the board with the multimeter power supply set to 11 volts. We limited current to 20 milliamps. You can see it says 10 on there. It's right on the edge. Sometimes it kind of goes to 9, and we will zoom in. And first thing we'll do is measure the current with the multimeter. It's a little bit more accurate. Set that to milliamps. For this particular one, I can leave the probes and everything where they are. We have to open the circuit to measure the current. So if you want to do that, you have to open the circuit. Now we will look at the current on there, and there you can see it's a little bit over 10 milliamps. So it's not going to be exact. Now we can look at the resistance, the way that we have this here. And so first we can measure this one. So even though it's connected to the power supply on one side, it's not to the other. Do not measure current, or measure resistance, I mean, if current is flowing through it. But we are open on one side, so we don't have to worry about that. So this is a bit shy of 1000 ohms. Looks like even more than 1%, I think. But over here, there you can see we got a little less than 100 ohms, but it's pretty close right there. So that was their resistances. Now we'll measure the voltage across there. Again, make sure no current's flowing through it. When you measure resistance, I can go to voltage right there. And so first we'll look at the total voltage, and there you can see it's a little shy of 11. So there's a little resistance where these connections are and stuff, and so that's going to take away a little bit of the voltage. But there we got 11. We can go across the one resistor, and it's really close to 10 right there. And now we'll go across the other resistor, and it's just a tad bit above 1. So this is not as much lower as that one from its rated value, and so it's picking up a little bit more of the voltage, but it was still pretty close, as you can see there. So this is not a precise circuit. We would have to do more to make it one, but this is close enough just for general circuitry stuff. So make sure you turn the meter off when you're done. Definitely get it off of measuring current if there's a power button. Check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I have links down in the description, but just watching as many videos as you can helps out a ton. Thanks for that. I'll see ya in the next video.